There are some important things to remember when we are carrying out AC circuit analysis. One of the major among them is the value of the voltage source written in manners like this. V is equal to, let's say, 5 cos omega t, or even the current source may be written as 5, or let's say 15 sine omega t plus 30 degrees. The important thing here is to understand that for solving, we have to convert this into phasor form, which in this case it will be 5 angle 0 degree, and in this case it will be 5 in terms of cos. If you are going to write in terms of cos, then it will be 15 angle minus 60 degree. How we are arriving at this? For understanding that, it is important to understand this figure. Always remember, this figure will be helpful to us to write the voltage in phasor form. Now, the important thing to remember here is that this axis is always denoted as cos omega t. So the opposite of that is minus cos omega t. And 90 degrees behind cosine you have sine omega t, and opposite of that you have minus sine omega t. Now if we are going to talk about phi cos omega t, I can directly draw here a vector which is of the length 5, and it's in this direction, so it is cos omega t. So this is 5 cos omega t. Now how does the angle 0 come here is by always trying to find out what is the angle between the drawn vector and cos omega t. Always it will be with respect to cos omega t. Always the angles will be measured with respect to cos omega t. If the angle is going in this direction, it will be positive. If it is going in this direction, it will be negative. That means clockwise it will be negative and anti-clockwise it will be positive. So let's take this case, 15 sine omega t plus 30. Now sine omega t is this direction. Plus 30 degrees from sine omega t means you have to take an angle which is 30 degrees plus. So plus, I have already told, positive is clockwise direction, and this one is, sorry, this is counterclockwise direction and this is clockwise direction. So positive is always counterclockwise direction, so I'm going to take counterclockwise direction. I have to take 30 degrees. And then I will draw this one which is having a length of 15. So this will be 15 sine omega t plus 30. Sine omega t plus 30. Plus 30. Now this one can be written with respect to cos omega t, because we have to, I told you, always the angle that we are going to write here should be written with respect to cos omega t. So this vector is, since this is angle 30 degree, this should be 60 degrees. So this is in clockwise direction, which is negative. So this is minus 60 degree from cos omega t. So we can write this as 15 with an angle of minus 60 degree. Let's talk about another case wherein the angle is, let's say, if I'm going to write it as let's say voltage is equal to 5 sine omega t minus 20 degrees, then in that case how will I write it? So sine omega t minus 20, so sine omega t is this one, Minus 20 means I have to go in clockwise direction. In this direction I have to go 20, that is minus 20. So I am going in this direction minus 20 degrees, and suppose I am going to draw my 5, this is 5, yeah, vector of length 5. So this is now 5 sine omega t minus 20. So I will write it here, 5 sine omega t minus 20. This I have to see with respect to cos omega t. With respect to cos omega t, this is 90 degree minus, and then another minus of 20 degrees. So this I can write it as 5 angle minus 90 plus 20, which is 110 degrees. So the polar form of that is written in this way. Similarly, suppose I am having a voltage which is written as, let's say, 3 or minus 3 sine omega t plus 30 degrees. So minus sine omega t is this one, and you have to go plus 30 degrees. So from this one, plus 30 means I have to go counterclockwise. So plus 30 degree means I have to go in this direction. Let's say this is 30 degrees. So I'm going to draw a vector which is, so this is my minus 3 sine omega t plus 30 degrees. So from minus sine omega t, I'm going another plus 30 degrees. If it would have been minus 30 degrees, I would have gone exactly in the opposite direction. So this is plus 30 degrees. Now to write it in polar form, I'll have to start from here. This vector from here is going to be 90 degrees plus 30 degrees, which is 120. So this one can be written as, now I'm not going to write at minus, I'm going to write 3 angle 120 degrees. So this is going to be 3 angle 120 degrees. That's how we try to do for the case of voltage source or current source, whichever is written in terms of cosine or sine. Another important thing that we need to remember is how to represent the circuit elements. Now a resistor, if it is in DC, in AC it will be again represented as a resistor itself. If you are having an inductor L, in case of AC you have to write it as J omega L, or when we are doing Laplace it has to be written as S L. That means J omega becomes S. Now where do you get this omega from? Whichever is the circuit, from the circuit you will have either a voltage source or a current source. It will be written in either sinusoidal or cosinusoidal form, like let's say 5 cos 4t plus 30 degrees. Here this 4 is basically omega, which is 2 pi f, which is your 4 in this case. So for this one you will write the inductor becomes J4L. Now if your L is, let's say 2 Henry, if L is equal to, let's say 2 Henries, then you will write it as J4 into 2, which is 8. So it will be 8J. Similarly, coming to capacitor, in the case of a capacitor, from DC, when we are going towards AC, generally in DC it won't work, but I'm saying if it goes from DC to AC, I will write it as 1 by J omega C, where j I can take it to the numerator by multiplying and dividing by j, which will actually result in minus j divided by omega c. Or you can even write in Laplace, for the case of Laplace, you can write it as 1 by sc. So for our case, again, you are going to get omega from this particular value. So we will write it as, let's say, if C is equal to 20 microfarads, then we will write as the capacitor will be 1 divided by J into omega, which is 4, into capacitor, which is 20 microfarad, which, as you know, we can take this one straight to the top. So I will get 10 raised to power 6. J I will take to the top, so minus j 10 raised to power 6 divided by 4 into 20, which is 80. So I can straight away write this value. So whenever we are doing problem, either the circuit will directly contain the capacitance and inductance value, it will be given like this, or the capacitance and the inductance value will be given something like, as we said, 2 henries, or capacitance we are saying it is 20 microfarad, and you have to do this conversion, or you have to do this conversion for getting the value that you need to put for solving the equation. So that is the case with inductor and capacitor in the case of AC circuit. Always remember, for giving a slightly twisted question, the source may be written as cos 2 pi 6 t plus 20 degrees. So you have to take 2 pi 6 as the omega value. Don't take 6 as the omega value, because 6 is actually only f. So when you are going to take omega, it should be 2 pi 6 completely, if it is given in this form. If it is given in this form, then it is going to be straight away omega. Basically, whatever is there with t, that has to be taken as omega.